So we did a structure, and a structure is a collection of data elements. That way you can package all the information about a specific person or whatever, you know, their age, their the birth date, their name, that kind of stuff. Or if you're dealing in geometric shapes, you know, you could have a point class with an X and a Y component, a point structure with an X and a Y, or a circle that had a radius, that kind of stuff. But you can also attach methods to a class. Method sounds fancy term. All it is a function that is attached to a class. So you could have an employee class with a print function that's attached to it. We did a student class and we had a print function that would print the student, but it wasn't actually part of the class. It'd be cool if we had student S1 and then we could say S1.print, parentheses in parentheses, and then it would display it. So that's what we're going to work on today. If you think of a structure as being data and then a class as being data and methods or functions that act upon that data, that is conceptually correct, although as I've said in C++, the terms are, they mean almost the exact same thing. The only difference is that a structure, all the members of it are public, meaning that you can access them easily from outside of it, and a class, all the members of it are private by default. You can change that. You can make them public. Why would you do that? Because otherwise you can't call those methods or access those variables from outside of the class. So let's do this. Empty project. I didn't give it a good name, but that's okay. Let's do a new item. Put our boilerplate in, which I don't have anymore. So we want the using, include IOStream, # include string, although I don't think we're going to use strings in this example. Using namespace, int main, all of our good stuff. System pause for the PC users. And a return 0. Now we're good. Here's what we want. Get a note up so I'm making sure I'm not giving you any information and making more mistakes that I'll have to then correct. Okay. We're going to define a rectangle class that has a height and a width. So previously what we did is we used the word structure. We're not going to use the word structure. We're going to use a class. We're going to call it rect for rectangle. And now we're going to give it some data elements, just like we did with our student structure. But we're going to specify that we want these elements to be public. Public means that they can be changed and looked at by things that are outside of that class. We may change that before long, but we'll leave them public right now. So why not use ints? Int height. Okay, I'm sorry, I got the syntax wrong. Public colon. That's giving me an error. Okay, good, the error went away. So down here inside of main, we're going to create a rectangle, or maybe two. Rect R1, R2. So R1's dot height is equal to 10. R1's dot width is equal to 10. R2's dot height is equal to 5. R2's dot width is is equal to 20. Now for the student class, we had a print function, but we didn't put it inside the structure. We are going to put a print function in here. But let's add another one first. First, let's add a function that gets the area. So go back to your rectangle class and do public. And honestly, once you type the word public, everything after it is public. You don't have to specify it for each and every one. But in Java, you do. So I'm in the habit of doing it for everyone. So public int get area. It looks just like a normal prototype or normal function. It's arguing with me about the tabs. Yeah. Int area is equal to height.width. Return area. Now let's prove this works. Let's go down here and print out cout R1 area is followed by R1 dot get area followed by ENDL. And paste that line underneath there and do the same thing for R2. See that it ran. Error list.
I think your pause and return.
Or herpader. Yeah. Why don't we put the pause in front of the return? Okay. And it says R1's area is 100, R2 area is 100, and that wasn't my intention, but it's true. 10 times 10 is 100, and 5 times 20 is 100. I'm going to change this so that they're not both 100. I'm going to say that this is a 10 by 20. That way to say R1 100, R2 is 200. Okay, so we have a function called getArea. And we've proven that it works. Now let's add a print function. So public. Now this doesn't have to return anything. It's just printing. So we can make it void. Stop tabbing weird. Okay. So let's see out some information about the rectangle. Rectangle height equals height, ENDL. See out rectangle width. And then see out the area. Now we can't just see out area. Why? Because there's no area variable available to it. So how's it going to get the area to print it out? It's going to use its own getArea function. I forgot to put a call to the print function, so it didn't do anything different. But come down here and replace that cout line, or you could just comment it out. You can even leave it, but I'm going to comment it out. And then instead I'm going to call r1.print. And then I'm going to call r2.print. And it'd be kind of nice if we had some visual indicator of each new rectangle, so I'm just going to print out some dashed lines. Necessary? No, but it'll differentiate the two things. There we go. It printed out the height and the width of the first rectangle and the height and the width in the area of both of them. So that's all a class is. It's functions embedded in a structure. Now, if we were going to implement this correctly, we should move the class definition to a header file. And then you get into arguments with people who say that you shouldn't put code in a header file. You should only put the prototype. And that gets to be a bit of a pain. I'm not even sure I want to get into that. Yeah, let's do it. Let's do it. So, we know we're going to need a file called rect.h. So we may as well just include it even before we go add it. Include rect.h in quotes. It's telling me that, all right, then come up here and cut that entire class. Go over here to header files, right click, add, new item, choose header. Change the name of it to rect.h, R-E-C-T.h. Now we're going to add, remember last time where we did that if def, or if in def, and then we define something? Instead we're just going to use the pragma. Pragma means don't include this more than once if you have, you know, a series of includes. And then paste that class in there. It's going to complain that it doesn't know what cout is. So let's also add include iostream.h. Oh, not .h. What am I doing? That's a C programmer, not a C++. Okay. Then come down here, and where it says cout, just add std : in front of those, rather than adding the using. You really should not do the using namespace std inside of a header file. If somebody wants to put, you know, using std into their own code, that's fine. But when you're writing a header file, you don't really want to put that in there. Brings in too much. Defines too many things. Okay, now that we've done that, we can run it, and it'll work okay. Because all we did is move all of that stuff into a header file. But what happens when you run it, the # include inside the source, just gets the entire contents of that file and dumps it in here. So it should run the same way. It doesn't. Okay, excuse me. Also come over here to all these ENDLs and add std : in front of them. Some of y'all have been refusing, not that it's a bad thing. Whoops, what am I doing there? Declining to use, you know, the using namespace std, and that's a good idea in your professional work. Okay, so it ran. Why did that work? Because it put all of that code in a header file, and then the # include brings all of that back into main, which is where we had it to begin with. Okay, so what's nasty about this is that we have a header file that actually has code in it. That's not real cool. We ought to take this stuff out and put it into its own CPP file. So here's what we have to do. Come back over here to source files. Everybody get this far? I don't want to go blaze on ahead. Go back to source files and do add new item and add one called rect.cpp. On the top of it, do # include quote rect.h. Now we're going to have to move some things from the rect.h file into here. And I hate doing this because it kind of tears up, you know what? I may just ask you not to do this part, but just to watch it. I don't know. So we have get area here. What we would do to be the best, awesome, most shiniest programmers would be to turn that into a prototype. And then to cut that, the rest of that code, go back over here and paste it here, except now we've got to take out that word public because it doesn't understand what it's doing, and it doesn't know what get area is, so we have to add rect::: in front of it. And it's telling me it has no such member. Maybe I haven't saved everything. Get area identifier not found. Did I not? Oh, I left my semicolon there. That didn't fix it. I cut it out completely. I should have left the prototype there. Okay. Go back in. Public, int get area, like that. But it doesn't have any code. We're just defining a prototype, which is usually what you see in header files. And then I come back over here into my rect.cpp file, and there. The body of that method is defined in the CPP, whereas the rest of the definitions are in the header file. And this is extraordinarily common. Other programming languages don't make you divvy them up like that. For example, Java doesn't even have header files. All you do is you define the class in the Java file and you put all the data definitions and all the methods right there. But CPP has the idea that you're supposed to split them up, that you put the prototype for the class, all the definitions in the header file. So this, I don't know, if y'all want to do it too, that's fine. I would cut this, for example, and then I would put the prototype back in, public, void, print, like that. Then I would take what I just cut, go into rect.cpp, paste it, but I have to take this word out because that keyword makes no sense in this context. It has already been defined as public inside the header, but I do have to put rect::: in front of it, or else it thinks that we're just defining a local function rather than a method that's part of the class. So why did some languages do away with this idea of splitting what's known as the interface to the class, everything that's in the H file and the CPP file? Well, I'll show you. What if you decided later that you wanted the get area function to accept, for some reason, don't do this, an integer, and then it does something with that? Well, you also have to go and change it in another place as well. You have to go back into the header file. So you wind up making your changes to your prototypes in more than one place. And the good thing about doing this, though, is that you could compile your code into a library, give somebody the header file, but not the CPP file. Now, they may think that that's not a good thing. But, you're telling them, you give them documentation that tells them how to use the rectangle class, and you give them examples, but they don't get the source code itself. And there may be some knowledge in that, in that source code that's valuable that you don't want them being able to go in and get. Of course, nothing is impossible to get. You can always decompile an executable and understand what it's doing. But you know what I mean. It's the difference between distributing source code to somebody and letting them monkey with it, or giving them a finished product. And when you're making an API, quite often, if you're not just distributing it internally to other customers within your same business, you will make a library file instead and just give them the header file that uses that. Alrighty, so that's our class. How many did move the CPP stuff after I said not to? Okay, so hope you got the idea. A class is a structure that also has methods. When you're using either a class or a structure, you should move the definition to a header file. If you want to, the cheap and easy way of getting the code in the class as well is just to leave it in the header file as well. If you want to dot your I's and cross your T's, then move that stuff into a CPP file.
So when we moved it into its own CPP file, it knew it was public because of the header.
Exactly. That's a good point, though. I wanted to show this. Change that get area function to private. Then go back to your source and uncomment out one of those calls. I may have done the wrong thing. Yeah. Okay, so get area is private. So uncomment out one of those calls to get area. Now it's complaining. You can't use get area. Get area is private. Once you define something as private, the only way you can get a hold of it, or the only way that function can be called is from within the class. And why do you do that? That's called encapsulation. Normally what you do is you make your data private, not your methods. Because you make your methods so that people can use your code. But you encapsulate your data. You make it private so that we couldn't do this. If we went back in to rect and we made int and height private rather than public, then this code would not be able to set those directly. And you go, well, that's a pain. How are they supposed to set them? Well, what you do is you come back here and you add a set height function that sets that value. You add a set width function that sets that value. And I'm calling them functions, but they're really called methods. Whoops. And then you go back to your source, and when you want to try to set the height and the weight, instead you have to call those methods. The weight, width. So set height, I want the height to be 10. I want the width to be 10. So why would you do that? Is that just making yourself having a lot of busy work? Yeah, for a class that all it's supposed to be is an example, in a room like this, it is too much. But really, what you want to do is your set functions should be doing data validation. What if it's impossible in your world to have a rectangle with a negative height and a negative width? Then you would want to go and make your code not allow that. What if in your data in your student class you want to forbid having a student with a name that's only 1 character long or no characters long? Then you would change your set name function to do that validation. You could make sure that if you're writing something that's keeping inventory and it's keeping track of UPC codes or ISBN numbers or whatever, that they're not entering ISBN numbers that are too short. They have to fit the pattern. Or more complexly, you could make sure that if they're entering a credit card number into your structure, that it's the right number of digits, because all credit cards seem to have the 16 digits. I could be wrong about that. So you could make sure that somebody's birth date, hey, get my screen flash, sorry, that somebody's birth date isn't invalid, that they're that they have to have been born within the last 120 years, or you're not saying that they're born in in the year 2100 or something like that. So the reason for doing that is by encapsulating your data, by putting your data in a shell, and the only way that that data can be changed is through these functions. You can validate the data. You can be sure that your rectangle class or your student class or your book class or whatever has good data at all times. It doesn't have height and width values that are negative. Or if you have some kind of math class and you're going to be calculating the average, that you don't let the one of the values be 0 or whatever. Another reason is say that you had to have special access in order to access that type of data, payroll information for example. the program may need some kind of validation, and only if you have that level of validation are you supposed to be able to get the payroll, the person's pay rate. Well, the get pay rate function method could do that validation and make sure that the user had that ability before it would allow that to be returned. So you're encapsulating the data, you're putting it into a shell, you're making sure that all the data in your object is as valid as you, the programmer, can be. And that way, when you hand this off to somebody else, they can't mess it up. They can't cause your thing to crash by setting the height and width to negative values, or by setting a name, equal to null characters, or embedding SQL commands inside a name, so that's really bad things happen when it's run, or whatever, So that is why the rule of thumb is generally make your data private and your methods public. That's why when you make a class, things default to private. If I took out the word private here, it would work just the way it did before. I'm going to leave my print function public. Now that I've set public, set height and set width are already public. Like I mentioned, you don't have to do that every single time. Get area, well, whatever, private, public, however we want to do it. All right, that's the idea of classes. One more topic, references. References are when you need a job. No, wait, wrong kind of reference. We have talked about the fact that, I believe, that if you have some code that looks like this, I'm going to go back to main, that if you have a function like this, void do 0, and you take a variable like this, and you set it equal to 0 in there, go ahead and type this part. And so then you define a variable, and then you call 0, and you pass a in there, and then you print that out. If I change a up here to 100, and then I call the 0 function, is it going to set the value of a to 0? Or is it going to leave a at its original value of 100? We're going to run it and find out. And I've made too many errors in my other code. Oh yeah, height and width, okay. I'm just going to comment all references to R2 out because I only fixed that for R1. There we go. There we go. It still says a is equal to 100. And you might think about it, you might go, well, why isn't it changing it? I passed a in. It's because a is getting a copy. Excuse me, the parameter x is getting a copy of whatever argument is being put in here. This is called pass by value, or pass by copy. Just because we're copying the number 100 in here doesn't give us magical access to this variable. It's like we did this. Don't make this change, because I'm going to undo it. Int temp is equal to x, and then temp is equal to 0. This is in effect what's happening. We're defining a local variable here called x. Just like this one. This is a local variable. Once we copy x into temp, if we start changing the value of temp, do we expect that to change x? Somebody say no. No. Nope. Yeah, okay. So, what if you really did want that function to be able to change it? You have to pass it in as a reference. A reference means, oh, and one more reason why you would not want this to be able to change the value. What if you did this? What if you passed in 9? Is this supposed to magically somehow rearrange the universe's math system so that a 9 is now equal to 0? No, this 9 got copied into x. X is now just holds the value 9. We could do anything we want to with x, but it doesn't change anything down here. But what if we wanted it to? What if we wanted to write functions that would actually change the ints, or the strings, or whatever we passed in there? You can do that. 2 ways: pointers or references. Pointers are old school C things that have been around since 1970 or whatever. So we'll demonstrate that first. What you do is you define it like this. You put an asterisk in front of it. X is no longer an integer. It's now a pointer to an integer. And what is a pointer? It's something that can hold a memory address. So instead of handing you a copy of a piece of paper that has a copy of the value, instead I'm effectively giving you the address of that piece of paper, and if I tell you to change it, you're going to get up and change it. I want you to do that now. No, I'm kidding. Okay. Now this isn't going to work here. This x is equal to 0. That's just changing the value of the pointer. It's making the pointer point to 0. We want to change what the content, what that thing is pointing to. That broke this though. When we call the 0 function, we no longer have a type match between the parameter and the argument. We're passing in an int, but the parameter is supposed to be a pointer to an int. So we have to convert this to be a pointer. And we do that with the ampersand. And you can think of that as the address. We're not passing the variable into the function. We're passing the address of that variable into the function. And now he can do stuff with it that actually changes the value of it. When we run it, now it should say that a is equal to 0. And it does. Are pointers awesome and great? Absolutely. Do pointers cause the vast majority of crashes in system software? Absolutely. Because it's just a pointer. It could be pointing, it could have any number in it. It could have the number 8 trillion in it. What if your machine doesn't have 8 trillion bytes in it and you're telling it to read or change an element, memory address 8 trillion? It's not going to work. So pointers you have to be careful about. C++ added the idea of references, where you can define a variable differently. Another drag about pointers, and it's not a big drag once you get used to it, is that you have to change the way you call a function. Oh, I'm not going to make a big deal about that because we have to do that when we're dealing with references too. Okay, so let's write another function called 1, which will take that parameter and set it equal to 1. And down here, let's pass that in. Now a is not going to equal 1. This has the same problem that this code had before we changed it to these pointers. We're going to change the parameter here so that it's what's known as a reference, so that it gets the original object rather than a copy of it when you pass it in. And you do that with the ampersand sign instead of the asterisk. This says, I'm getting an int passed to me, but I'm not just getting a copy of it, I'm getting the original. So when it changes it, when we call 1 and we pass this variable in, and then we set it equal to 1, it actually does change its original value. So when we run this, it'll print out that a is equal to 1. And so it did. Why is that better in some uses than pointers? Well, because like I said, when you reference a pointer, you're not absolutely sure what memory address is pointing to, and you can conceivably cause your program to crash. And back in old days, before memory protection would prevent your application from changing memory that it didn't even have access to, then it could actually freeze the whole computer if you did that wrong. But with a reference, that's not going to happen. The worst is you're just going to make some data invalid. If the data is not supposed to be 1, then, well, you made it invalid, but that's your fault. You're a programmer. And doesn't crash the program or whatever. It doesn't cause one of those systems. Your application has performed an illegal function. It is shutting down. You know, it doesn't kill it just because it's setting it to a 1. So that's the two different types of mechanisms that allow you to pass data in, pass a variable in such a way that the method, that the function or method actually can change it. This is passed by pointer. X is a pointer to an int. This is passed by reference. X is a reference to the original. When we invoke something and it's supposed to be a pointer, there's always more than one way to do it. You could do this. Int star PA is equal to the address of A. I'm just going to make this as hard to read as possible. But there we go. We're saying that this is a pointer to that object, to that variable, and now pass that pointer in. That does exactly the same thing as what I had before when I had ampersand A there. So here we are passing the address of A in, and here we're actually passing in A in itself. All right, we're done. That makes sense? As much sense as a 130-minute topic could hammer it in. So when you become a C or C++ programmer, you will hit the idea of pointers. And if you become a C++ programmer, you'll hit the idea of references. They're very commonly used techniques, and I really need to try to make sure that they get referenced earlier in the class. No pun intended. But you now know that you have the concept, and you can go, and research it when you actually hit them. If you go on to deal with Java or Python, you will find out that they don't do pass by reference at all. It's one way that they make the languages more safe, and they also don't deal with pointers. So not every language gives you this option, but C++ does. C++ gives you a lot of rope with which to tie things up or to hang yourself. All right, we're done. Let's make a Dropbox. This will be R. Cute. R for rect class and references and pointers. And we'll make this a bonus assignment, so y'all can get extra credit for being here. Okay, it's there. You can upload. We have 3 files to upload actually. We have the rect.cpp, the rect.h, and whatever your other source.cpp was.